Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, we are going to solve another question of the June 2024 chemical science paper, that is NET exam. It is based on epoxide ring opening, which follows basic SN1 and SN2 type mechanism. Okay, so this is a reactant that is given, that is alkene. It reacts with MCPBA, okay, to form an intermediate product A, which then reacts with sodium methoxide to form product B, and the same intermediate compound reacts with methanol in presence of HCl to form the intermediate compound, the final product C. So the question in this question asked is, what are the products B and C? Okay, so let us first try to understand what is the role of MCPBA here. So this is the reactant. Okay, what is the reagent that is given? MCPBA. What is MCPBA? Metachloroperbenzoic acid. What is benzoic acid? Benzoic acid is benzene C double bond O OH. Okay, metachloro. This is ortho meta. Meta position, there is chloro group, and it is perbenzoic acid. So it is a per acid. So here there will be a peroxy linkage. Okay, so this is the structure of MCPBA. What is the role of this reagent? It is used for epoxidation. Okay, what is epoxidation? Formation of the epoxide ring. So what is the intermediate compound A that is forming? That is this. Okay, epoxide ring is formed. Okay, this is the intermediate compound A. Now this will react with sodium methoxide. This is one reagent, and it reacts with HCl and methanol. So let us first see what happens in the presence of methanol. Oxygen, here it has two lone pairs. The first step is this will coordinate with this HCl. Okay, it will get protonated. Why this protonation takes place? So that this oxygen will get a positive charge and it will become less stable. Okay, making these and these carbons more electrophilic, so that the substitution reaction can take place easily. That is, a nucleophile can attack easily. Okay, so first step is protonation that is taking place. Now the question is, here if you see in methanol, here oxygen has two lone pairs. Okay, but if you see the structure of this is MEO minus and Na plus, that is methoxide. If you see the structure, what is methyl? This is CH3 O minus. O minus means oxygen has three lone pairs. Okay, so here you can see there are three lone pairs. So this is more electron rich as compared to methanol. So here it is a very good nucleophile. Okay, or we can say strong nucleophile is present. So in this case, which type of mechanism is followed? In presence of sodium methoxide, it is the SN2 mechanism that will be followed. And always remember, whenever acidic medium is present, there will be a formation of a carbocation, and eventually the mechanism followed will be SN1 mechanism, SN1 substitution reaction. So now the question is, here there are two bonds. Okay, one is this bond. Let's say this is A, and then there is another bond, that is this one. Let's say this is B. So which bond will break? Suppose if I break this bond A, which carbocation is formed? A tertiary carbocation is formed. Okay, and suppose if I break this bond B, here if positive charge is formed, it is the secondary carbocation is formed. So which is more stable? We know tertiary is more stable because here there are two electron donating groups, whereas in case of secondary, okay, here in tertiary there are three R groups that are donating. Tertiary is more stable. Okay, so let us draw again. So which carbocation will be formed? It is the tertiary carbocation that will be formed. Okay, so it is this bond that will be breaking. Here we will get the positive charge. Okay, oxygen will get back its lone pair, and the next step is attack of the methanol. Okay, this will attack here, Okay, a bond is formed between oxygen and this. Oxygen will get a positive charge. Then Cl minus will pick up this proton and will get the final product. Okay, what will be the final product? Here there is OMe. Okay, then there are two methyl groups. Okay, and then there is methyl and OH. Okay, so which is this product? This is the product C. Okay, so in the options you can see there are two such options. C, okay, OM is present on this carbon, OM is present on this carbon. So either the answer is option 1 or option 4. Okay, now let us see the other one, SN2 mechanism. Okay, so how SN2 mechanism takes place? This is the nucleophile and it will attack the less hindered site. So which is the less hindered site? Here you can see there is only one methyl group. Here there are two methyl groups. So this is causing more steric hindrance. So the attack will take place at this position. Okay, so here it will attack and this will open up like this. What will be the final product? OH. Okay, here there is OMe and then there is methyl group. This is the product B. So you can see B is which one? Where OM is attacking at the less hindered site. Okay, so what is the correct answer? Both B and C are same? No. Okay, option 1 is incorrect. The only correct answer will be option 4. Okay, I hope you have understood this mechanism. Always remember, whenever there is presence of acid, okay, a carbocation intermediate is formed. We know in SN1 reaction, that is what that carbocation intermediate is formed. So in presence of acid, SN1 mechanism takes place, and in presence of if there is no acid, it is a good nucleophile, then SN2 reaction takes place. I hope you have understood this solution. Thank you.